I'm going to cover properties of infinitely large or infinitely small numbers. So real quick, uh, definition of infinitely large and infinitely small functions. So let's assume we have x0 that to be either endpoint or point at infinity, which is going to be at infinity, positive infinity, negative infinity, or positive infinity itself, including positive and negative, and then it can be negative and it can be positive infinity. So, which means I can write down in the form, the mathematical form, which is going to be limit of function a of x is equal 0 when x is approaching to x0, end point, approaching to end point, or point at infinity. So this is definition of infinitely small function. Infinitely large function, the function f of x, the limit of function f of x running to infinity as x approaching to endpoint x0. So this one is going to be infinitely large function. Okay? So now let's look at the properties of these infinitely large or small numbers. So here is the properties. If you have positive infinity plus another positive infinity, result is going to get positive infinity. Next, if you have negative infinity, adding another negative infinity, you are going to get negative infinity. It's like example, if I get negative 7 and negative 5, I'm going to get negative 12, right? Okay, next one. Positive infinity minus negative infinity. What's going to happen? Negative and negative, it's going to be positive. So you will end up with positive infinity and positive infinity. Result is going to be positive infinity. Next, negative infinity minus positive infinity. It's like negative infinity minus negative infinity again, right? So it's going to be negative infinity. To take example, let's say negative 5 minus 3 again. All right, next one. Infinity times infinity. It's going to be equal infinity. Okay? If I have, let me see, I want to squeeze this a little bit, not like that. Wow, it's not listening. There we go. You know what? Let me write down real quick. It would be easier. Okay. Infinity times infinity. We are getting infinity. Done. Next, infinity multiplied by positive infinity. Like I said, infinity includes itself in positive and negative. So infinity times positive infinity, it's gonna give us infinity. And third, infinity times negative infinity, it's gonna give us infinity. So infinity is bigger than positive infinity or negative infinity. It's going to absorb and positive infinity and negative infinity. Next, positive infinity times positive infinity equal negative infinity times negative infinity, because positive times positive is positive, negative times negative, it still gives you positive infinity. Next, positive infinity times negative infinity, it's going to be equal negative infinity times positive infinity, because negative times positive or positive times negative, it's going to be same negative, in this case infinity. Infinity is a concept, it's not a number, obviously. But you can, to understand these properties, you just take some example with positive number, negative number. Next, from the previous videos, we already know that 1 over infinity is going to give you 0. Excuse me. 1 over positive infinity, it's going to be equal it's going to equal 0, but that's approaching from the positive side. I'm going to cover also, it's going to be one side limit also after trigonometric limit with trigonometric functions. So because it's like, let me see, this is your 0, this is positive infinity, this is negative infinity. You can approach the one, if it's one side limit, we will learn what is one side limit in a video or 2 videos, I will explain. Or you can approach 0 from the positive infinity. So how do you know from which side we are approaching 0? If it's positive infinity, then 0 is from the positive side. If it's negative infinity, 1 over negative infinity, it's going to be 0 from the negative side approaching. Okay? Next, what else it can be? Yes, now let's explore some arbitrary real number and manipulate with infinity, see what we get. So A is an arbitrary number, real number. Arbitrary real number. Okay, so what we are going to get here, what cases? A plus infinity, number plus infinity. In my previous video, I said I don't care how large number is. If comparing to infinity, it's like a drop. So it's going to absorb that number, infinity. It's going to be equal infinity. Next, A minus infinity. It's going to be negative infinity, right? Because it doesn't matter how large A is going to be. Because we said real number. See? So A minus infinity is going to be negative infinity. Next, A plus positive infinity, one side infinity, it's going to be positive infinity. But if we take a minus positive infinity, so it will become negative infinity, right? So the answer is going to be negative infinity. Next. A plus negative infinity. Again, it's going to be negative infinity. Maybe I should move on this side. Let me move on this side so we won't go beyond of page. Stick here. All right. And a minus negative infinity. So my negative, once you open, become positive, right? So it's going to be equal plus infinity. Okay. All right. Now let's look when a is greater than 0. So let me underline this. So looking, let a is greater than 0. Then, what do we get then? A times infinity. There is no, how to say, there is no number big enough that can take over infinity. So infinity is going to absorb any number. It's like infinity is like galaxy. What is planet in the galaxy? Nothing. It's one dot, 1 point. So that's what infinity is. So any number multiplied by infinity, infinity gonna absorb real fast. So it's gonna be infinity. Next, a times positive infinity, one side infinity we're looking at. It's going to be positive infinity. That's because a is greater than 0. Next, a times negative infinity. So a is greater than 0, which is positive. So it's positive times negative. It's going to be negative. But we are figuring out the sign, but not the infinity, because it's going to be infinity period. Next, let a be less than 0, which means we are taking in this case a as a negative number. Then we are getting a times infinity. If it's negative, a times infinity. What's going to happen? It's going to get infinity, because this infinity is include and positive and negative. But if I take a, multiply by positive infinity, I'm going to get -1. Why negative infinity? Why? Because a is negative, multiplying by positive, it's going to get negative. Negative times positive is negative. And if I multiply a by negative infinity, what do I get? Negative times negative, right? Because a less than 0 is negative. Result is going to be positive infinity. All right? Okay. So we can apply these rules to some limits. So let me put some example here. If the limit, I get limit f of x that is equal a when x approaches to x0, and limit of g of x is equal positive infinity when x approaches to x0, and in our case a is going to be greater than 0, which is going to be finite positive number. Okay, then what do we have? Limit f of x plus g of x when x approaches to x0. It's going to be equal. Limit f of x is a. Limit g of x is infinity. Positive infinity. I'm sorry, we have positive infinity there. So let me squeeze in positive infinity. And the result is going to be positive infinity. By the way, in Europe, sometimes when positive infinity, they put dot, 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 which means it's eternity, it's continuing, endless. Next, limit f of x, applying the properties to an enormously large number, minus g of x when x approaches to end point or some point at infinity. It's going to be a minus, since we have limit of g of x positive infinity. So what's going to happen? It's going to be equal a minus infinity, right? Result is going to be obviously negative infinity. Next example, limit, or rather saying property, multiplication g of x and x approaches to x0. So what do we have? Limit f of x is a times positive infinity, and the result is going to be positive infinity because a is also greater than 0. So positive times positive is positive infinity. And next, limit x approaches to x0, f of x dividing by g of x, quotient rule. It's going to be f of x limit is a dividing by positive infinity. That means how to do this case. I'm doing a little bit the notation. I'm rewriting a times 1 over positive infinity. We know 1 over infinity is 0. And so which means 1 over positive infinity, it's going to be plus 0, or we put 0 from the positive side, right? And it's going to be 0 from the approaching from the positive side. It's one side limit I'm using here. Okay. Maybe one side limit, it's confusing you a little bit right now, but I'm going to record in pretty much in detail one side limit so you can understand well. Okay. So next, let me see. What else is interesting? Yeah, there are cases that are going to give us uncertainties. And so what cases are that? Not always using the only arithmetic properties of the limits for enormously large numbers, like it's gonna lead to the result. Sometimes it stays under infinity and infinitely large and infinitely small functions. I'm going to look at such functions also. So, but that's I'm going to record in upcoming video. So I'm going to record limit for trig functions, and then one-side limit, and undefined limits also. So there are limits with enormously large and enormously small numbers that you don't get a limit to that. Okay, thank you for watching. See you in next video.